nunchuck skills, bow hunting skills, computer hacking skills.
All right, so quick shout out to Napoleon Dynamite right there. Gotta love that. I made this meme myself here. I nailed it. I think actually somebody else's meme, and I changed it to calculator skills. But I add those calculators. That's Adobe Photoshop. Pretty amazing. Let's get rolling on the calculator skills. So a whole section on calculators. Why? Well, check this out. Let's take a look at the AP exam. Look at this. This is how much calculator we're gonna or you're gonna be required to use on the exam. So if you look at it, 17 of the 45 multiple choice are calculator and 2 of the 6 free responses. You're going to be able to use the calculator. It's over a third of the test right there, so it's very important that you have these skills. So some people love the calculator, they're fired up, they'll be happy to see that. Some may be like, oh, I need a refresher on this. So this video is going to be a refresher, and to kind of get you going with the whole course here, you're going to love this sign, I hope. All our packets are designed so you're not using the calculator, including mastery checks. You're not allowed to use a calculator unless you see this sign right here. This is where it's all at. This is what we expect you to use the calculator, so it's a big hint that you're going to need to use the calculator. So that is the only time. So practice, make sure you're doing the packets without the calculator. Unless you see this, then break it out. Use that calculator. Let's get these skills. I was a little nervous this would be a long video, so I made this table of contents so you could jump ahead. Even if you're really good, I'd watch through this one time. Maybe you don't need to pause it at all just to see all the stuff I'm going to cover, because maybe some stuff you haven't seen, especially at the end. If you're a little rusty on this thing or a little shaky, you're going to need to pause and rewind and watch this a couple times, because I'm going to move fast. I'm going to assume that you have some experience, you know what I'm talking about, so if you need to jump ahead after you've seen it once, this is a good reference point for you. All right, so first thing we need to know, calculator is always going to be in radians. We don't deal in degrees for the AP exam, so make sure right off the bat, take your calculator. Let me put mine in the screen here, and you go to mode, and mine is in degrees. Don't do that. Always check that we are in radians. Everything is going to be in radians, so first thing, put yourself in radians, stay in radians, don't leave radians. Calculator tips, I wrote these down for you, so I'm going to, you can read them yourself here, but don't do unless if it's going to make things faster for you. If you use it on the free response, you must justify it. So you can't just magically write down x equals 4. You need to tell how you got x equals 4. What'd you put in the calculator? We'll talk more about that later on, but you need to justify calculator work on the free response. Multiple choice, who cares? You just need an answer. Number 3, don't round to the very end. So they're very specific about how many decimal places. If you round early, well, it's going to make your answer off, and then you're going to lose points. Speaking of rounding, there's a difference between rounding and truncating. You can choose. You can round or truncate to 3 decimals. So what does that mean? So rounding, we know if we're going to round to the 3, so tenths, hundredths, thousandths. So this is the 3rd decimal place. Truncating is easy. Truncate means cut that bad boy off. Boom. 43.5827. You don't even look anything after that. You have truncated that. That's the one I prefer because it's just easy. I don't have to do any extra thinking. That's good for my brain. But if you want to round, what would you do? Now you look at the next number. You look at the number after it. It's above 5. So if I were to round, it's going to be 43.58. That 2 turns into a 3. So a lot of times you'll see me write answers like this, and the answer key is 43.5. 82 is one of them, /3. Either one of these would give you credit on the AP exam. You choose one of these. I'm more of a truncator than a rounder, but whatever you want to do. How about this, just so we have it? Again, if I was truncating, I would go to 3rd, always 3 decimal places, and I would say it's negative 4.99. No thinking at all. Oh, well, if I rounded this one, what would happen? You would actually get the same thing. So sometimes it's the same number anyway, because the 2 is not going to round it up. So pick whatever you want, but that's how the answers will read, so don't freak out if you see that slash. Either one is right. But again, if you round earlier, you're not going to get this answer, so don't round. Leave that big decimal in there until the very end, then round the final answer. Awesome. Let's get this rolling here. Common mistakes. So this can happen to the best of us here. So let's start looking at these right here. The first one, if I want to evaluate this, like, yeah, no problem. Probably not a calculator problem here, but a lot of people will type in -3, hit that little squared button, -4. You're evaluating when x is -3, calculator is -13. That is definitely wrong. Remember, this negative, it's really the -3 is being squared minus the 4. So if you're going to put that in the calculator, again, probably not this example. You'd probably do that one without it. But if you had a more challenging problem, you must square it, because we know when you square a negative it's positive. But the calculator actually was going to take the 3, square it, then makes it negative when you put it like this. Over here, now it's going to square the -3. Now you get the correct answer of 5. So be careful with that. That is a common mistake. Another common mistake is, again, x is 7, so you're putting 7 in the equation. So you want to take 7 and divide it by 2 pi. So yeah, that's great. We're going to take that, plug it in the calculator. So what is 7 divided by 2 pi? Well, a lot of people will do this right here. This is wrong right here. That is not the answer. This is 7 divided by 2 times pi. Way different answer. So what do we want? We want 7 divided by, you got to put in parentheses. So parentheses are hugely important. Now it's the 7 is being divided by all of the 2 pi. Big difference right there. That is the correct answer. Let's just practice rounding. 1.1 or truncating. Boom. That is the correct answer on that one. Fantastic. I threw this bad boy up here too because what happens when I take something x to the 9th? This is going to be a big number, yeah? That's the whole idea here is what do you do when you get 47 raised to the 9th? Remember, if you get the new operating system, you got to hit right to get out of the exponent here. The -4, I don't think it's really going to, let's see what happens here. I don't think that's really going to matter. What is this? Is 47 raised to the 9th power really 1.19? Well, what does this E mean? That is scientific notation. Let's bring this bad boy in here so we can talk about him. This means 1.119 times 10 to the 15th power. So it moved that decimal 15 times, so it's a ginormous number. So really probably that -4 isn't even showing up on this because -4 would be way out here. So it's this huge number. So if you get this E, it's really big or really small. If it's -15, it'd be really small. Positive, really big. So a lot of people would just be like not thinking 1.19 is in that they'll just round it to this and say that's the answer. That is wrong. Don't do that. All right, common mistakes done. Let's do trig functions. So hopefully when we're doing trig functions, remember cosecant. I'm just evaluating this. What is the f of pi over 5? So if I'm doing it, I got to think about what is cosecant. It's really sine. So you're really saying this right here. So plugging that in, again, we're always in radians, so we're always good to go there. I'm going to do 1 divided by, what do we say here? The sine of pi over 5. So I just don't want you to freak out when you see these things. It could be, maybe it's been a while, but this is 1.701. Oh, I like these. It doesn't matter if you truncate around, you're going to get that. Okay, so when we're talking about sine squared here, that's different. What does that mean? Sine squared means sine theta times sine theta. So you can actually, if you want to put them in parentheses and multiply them, type that in your calculator. Or you can do this in your calculator. You can put it all in parentheses and square it, but don't do this. Sines, don't square it here because that's only going to square the angle. So don't do this one. So you can type it twice or you can do it like that. I don't really care either one. My personal preference is, because I think it's less typing, is I actually will do this. I'll do the whole thing squared. So I'll do 2 divided by, and again, I tried to trick you here with that 3 pi. So I'm going to have to put that in parentheses. So I've got the 3 pi in the bottom. So now notice what I'm doing here is this, I'm closing the parentheses of that's the angle. 2 divided by 3 pi is the angle. I'm signing it and I need one more parentheses because I'm going to square it. Holy cow. And this should be my answer right here, 0.0443. And again, I'm going to truncate it. If you didn't truncate it, what could happen? You could have rounded that one up. So be careful with that. Either way, if you want to type it out twice, I just don't want to type that out twice. So I square it with parentheses like that. As long as you get that right answer, I am good to go. Fantastic. Well, we're cruising. All right, so now we're going to look at some other features here with the window trace, all these different things. So again, I know you could do these without a calculator, but I'm just kind of showing you what we can offer here. So if I want to evaluate something, yeah, you can just plug it right in, but I'm actually going to graph it to show you some of these features. So sometimes, whoa, it's just nice. Whoa, what am I doing? Let me start that over. X squared minus 4. So if you zoom standard, this is the basic window. So this is the 10 in every direction. 10 x max, x min, -10, y max, y min, -10. So if you look at your window, that's how they relate. You are showing 10 in every direction. So that's our whole min, max, all that fun stuff there. In fact, I'll bring this over here so we can look at it. What do I want to do with this first? Well, we can trace it. If you trace on the function, it shows you the coordinates. It's really nice. Here's when x is 0.85, y is -3.27. Awesome. Problem is this is based on the pixel setting in your window, and it's jumping around these random intervals here. So not, can I hit 3.2 exactly? No, I can get pretty close. But if you hit trace and then type in 3.2, that's what I'm trying to evaluate, and hit enter, boom, I actually can hit it exactly. So you can actually get exactly the answer you're looking for. So if you hit trace, type in the number, that's pretty cool. What else can we do here? We can go to table. So above the graph in blue is table. If I hit second graph, table. Now yours will probably default to something like this. You can scroll up or down, and this is cool. It fills it in nice and neat when x is 6, y is 32. If you go to above window here in blue, it says table set. So we can go here and we can change the independent. Don't change the dependent. The independent is your x. We're going to change it to ask. And maybe I want to ask it different questions. So if I go back to table, I can say, hey, when is this, what is the y value when it's 3.2? And whew, luckily we got the same answer. So the table agreed with me in the graph there. But you can ask anything. Maybe you want to ask it 497. I don't know, maybe it's your favorite number. Boom, there it is. So you can ask it whatever you like. So that's kind of nice. Another feature on here that maybe you'll use if we go back to auto, that means it's just going to fill in the table for you. This right here tells you what number you want to start with. So maybe for some reason you want to start at 50 and count by threes. I don't know why, but maybe that's just what you like to do. And there it is. There's my table starting at 50, counting by threes. So you can do that. But I like to just ask it questions, seems to be pretty nice, or leave it in its regular thing. So that's the table. So window is kind of one of the trickiest parts of the whole calculator. This whole min, max, blah, blah, blah thing. And it's really hard in some kind of word problems. And that's what we're going to focus on at the end. But just so we know we're good here, obviously this is the x-axis. So this is the x max. That's the biggest x, and this is the x min, the smallest. So in the standard, you can't see the negative, but there it is. It's negative 10 to 10. And the x right there is scale, and you're counting by 1. So you can change that to whatever you like. And again, this is your y max, y min. So this may be pretty basic for some of you, but if you're new to this, that's what the window is. So I gave you a function we could see, but a lot of times you got to find the function. Whew, I did that fast. Can we do it with trig functions? Sure thing, man. Let's go to the next one and look at trig functions. So again, now I just want to throw an inverse trig function at you. Where's inverse trig functions? Well, it's right above it. So second tan is the inverse. And ours will say x, even though I'm using theta over here. It's the variable. And what do we want to do here? If I hit graph, I don't know what's going to happen. You can actually see it pretty good here. Dang it, I should have picked a better example where you couldn't see it. But to be safe, what we really tell you, if you're going to graph a trig function, we should zoom number 7, zoom trig. So what this does is it gives you that nice trig window. So we're looking from negative 2 pi to 2 pi. That's the basic window, and I think negative 4 to 4 over here. We can't see the pi, but 6.15 is essentially 2 pi is what we're going for here. So that's what we're looking at. That's a nice picture of it. And again, if I want to know where pi is, I'm going to hit trace, and then I'm going to hit pi, and there it is. That's how I like to do those. Boom. If I can see it, I can trace it, and maybe you remember that's what an inverse tangent looks like. Nice job. So we can do zoom trig versus zoom standard. I'm going to stay away from zoom fit. We'll talk about that a little bit later on. Oh, here it is, zoom fit. Dang it, I just said I was going to stay away from it. Can't stay away from it. All right, so let's type this bad boy in here. So we're going to use this one. Go to our y equals, and we've got x caret. We're going to raise that to the 4th, minus 3x cubed plus x plus 3. Okay, so we got our thing. I know it's zoom trig. I always start in zoom fit. Zoom 6. Maybe I'm going to see it, maybe I'm not going to see it. So actually, this you can see on the zoom standard. I hope I said that. Zoom standard. I always start in zoom standard. What if you would have zoom fitted this? Where is that one? I try not to use it or even show it. People love the zoom fit. They're like, oh, this will find it for me. Well, zoom fit is a calculator decides what viewing window to give you. So check it out. This is the viewing window. Now, is that a good picture of this graph? No, well, I picked one on purpose. That wouldn't work. So if you zoom fit, yeah, it looks like a parabola, and you're like, what is this window? You can even go to window and be like, oh, great, my y max is at 12,993, obviously. You know, not really a good fit. So we're going to try to always go zoom standard and then try to create our own window, which is much easier with word problems, and we'll talk about that. But this is a picture of my graph, and if you want to, you know, we don't need all this x min over here. If you don't like this wasted space, we could tone that down and say, yeah, we only need to see like to negative 4 on the x. So see how I trimmed that off, and now it's an even better picture. I got extra over here. Let's just trim it off. Let's get rid of that, like a barber, cutting it off. Oof, that was rough. All right, there we go. So that's a really good picture right there. And I want to find the max and min. So check it out. I got a minimum here, a maximum here, and let's just put it over here. We got 3 different points. Here's a minimum, and a maximum. So these are the extrema. That's called finding the extrema, or finding the max and min. So to find those, what do? We are going to hit second trace, which is calc, second trace. And I'm going to find, let's start with the minimum right here. Boom, minimum. And there's a minimum, it looks like right here. But the calculator doesn't know. There's two minimums. He doesn't know which one you're talking about. So he wants a left boundary. So I get on it, then I hit left a couple times. Make sure you're left of it. So I know that's the minimum. I am left of it. So hit enter there. Now I come back to where that minimum is, but now it wants me to get right of it. And I know I'm right of it because I'm above it over here. So what it does is it sets this window. See these two arrows? It's looking in here for that minimum point. You hit enter right there. Boom, that is the minimum. I'm just going to drag him over there just for now. Too lazy to write all that down. So that is the minimum. So can you do the maximum? Sure, do the same thing. Second calc. Number 4, though, you're going to do the maximum. And again, I'm already left of that max. I know there's the max. Hit enter. And then I'm going to come over right of it. Hit enter again. It wants you to guess. I just hit enter, though. I'm too lazy. You could go back and guess if you wanted. And there's the maximum right there. Boom. Fantastic. Let's just finish this up. Let's race right now. Who can get that one faster, me or you? It's on. I'm left of it. Then I want to get right of it. So it's not up or down. It's always left or right. It's only looking in here. Hit the guess. There it is. So there are all my maxes and mins. Awesome. So that's a great tool. We're going to use that one a ton. So we're going to practice that. Finding the zeros is also called finding the roots. So just throwing some different vocab, but they mean the same thing. Max and min are extrema. Roots are zeros. If I'm going to find the roots, it's the same function. It's where does it cross, here and here. So when I go to my second calculate, we're looking for the zeros. And we've got 2 of them again. So again, if I want to find this one, I know it crosses around 1.36, but I want to be left of it. So hit enter. Then I want to be right of it. Hit enter. Enter again. Boom, that is the 0. So that is one of the intercepts. There's the x-intercept. And let's race again real quick. We are going to find the 0 of the other one. All right, and I'm going to come over here. I know I'm left of where it crosses, and then come up here. I'm right of where it crosses. Double tap that because I'm not going to guess. Feel free to guess. There it is right there. So quickly, we just got a ton of information about this function. That's pretty awesome. So I know it's x-intercepts, all the max and mins, blah, blah, blah. We're good to go. Very cool. All right, how about point of intersection? So if we're trying to solve a systems of equations, if we have 2 different equations, let's type them in. I've got x cubed plus 3x minus 4. And I've got negative x squared plus 4. You can pause it if you need to slow me down on typing in these equations. And again, I'm going to zoom standard, so I have that standard window. And hopefully I can see where they cross. Boom, there we go. So I kind of picked a tricky one here. It looks like they'll cross again down here, won't they? Oh my goodness, did I do that on purpose? Let's investigate that. Let's go down here, see what I was thinking, because it looked like maybe down there at negative 50 or so, they may cross more. So there's the cubic. Okay, we're safe. I just want to make sure I don't think these 2 are ever going to meet here. He's going out faster than him. Okay, so sorry about that. I just wanted to double check. So they are crossing one time, and it's in the standard window, so I did hook you up. That was nice of me. You're welcome. If I want to find a point of intersection, I'm talking a lot for this. What's the intersection? Number 5. So it's the same kind of stuff. It wants first curve, second curve. So really, you can get close to where, because if they cross multiple times, it's whoever he's closer to he'll find. So it's first curve, second curve. Again, guess. But really, if there's 2 points of intersection, get close to the one you want, and it'll tell you that. There it is right there. Awesome. So there's my point of intersection. Cruising. Solving equations. This is also a great tool right here. It's the same one as before, so don't clear out your y1. I'm going to clear out y2. If I want to know when does this, and this is not a bad equation, but if it's like a log or something crazy, really helpful tool here. I'm going to graph both of them. I'm going to graph this in y1, the left side, and this in y2. So this is one equation. This is my y2. And what happens here is, check this out. My y2 is the constant 5. There's 5 right there. And I want to know, when does this cubic function equal 5? So now you can do that point of intersection we just learned. What's the point of intersection? Well, you can kind of come over to where it crosses, do your little tap, tap, tap. Boom, gives you the intersection. That's great. Some people prefer to actually subtract 5 from both sides. And if you subtract 5 from both sides, we've got a new equation, plus 3x minus 9 equals 0. And now you can make this your y equals. So some people will go back and change your, instead of saying when does it equal 5, if I get it equal to 0, then what I can do here, that change that to 9. Oops, change that to 9. Now when I graph it, what am I looking for? I'm actually looking for the zeros. I'm looking at, hey, when does it cross the zeros, which are your solutions? And boom, let's just find them real quick. I'm cruising, man. We get the same answer. We got the same answer, so we know we did it right. Very nice. All right. This is probably going to be new for you guys. Check this out. So I'm saying x is the sine of pi over 7. Nasty decimal right there. I figure that's got to be terrible. Then I want you to take that and plug it in there. So let's just first start with, well, what is the sine of pi over 7? So pi divided by 7 is what? Yeah, look at that. So are you going to want to go 3 and type that whole function in? 2 radical, that whole thing? Like, you're going to want to retype that every single time? No way I want to retype that, because you need all those decimals. Or you can store it. So let me make sure you can see where I'm at here. Down here. Whoa, I really went for it there. Let's try that again. Okay, there he is. Down here, right here, is the stow button. Like, you're going to store it. It's the store button. So I'm going to take this, and I'm going to store it as any letter you want. I usually just go alpha A, because it's easy for me to remember where it is. So I'm going to store it in alpha A, hit enter. Now it's stored in there. Then I can go back, once it's stored, and I can say, okay, what is 3 raised to the A? And then minus 2 times the square root of alpha A. So there it is. So it's putting that 0.43388 blah 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 minus 4 times alpha A. Check that out. So I know you're really storing it if you get this decimal. If you have to type that in, you're crazy. There it is right there. So this will help you not round until the end. I'm going to store that number. I'm not rounding at all. Boom. Now I can do my rounding or truncating and say, yes, definitely that is the answer. So that's pretty awesome there. Okay, let's put this equation in. So it's x to the 4th here. So let's put this bad boy in. Like the old one we had in the systems, but I made this 4 so they would hit twice. When you graph it, you get this. So I want the x-coordinate of the left point of it. So essentially I want to know where does it hit here and where does it hit here. So if I go ahead and hit second calculate, remember the point of intersection, number 5. Get there, number 5, boom. And let's come over here. This would be the left point of intersection. So we're going to come over here and say I'm closer to this, so it hits first curve, second curve, guess. There it is. So again, look at this crazy number. It's a really long number. So I'm going to quit out of this. I'm going to clear out of that. And what I'm going to do is I'm going to go ahead and store it as alpha A. And check it out. There is that number from our graph, that negative 1.78. Then I'm going to come up here and do the same thing again. Point of intersection. And I'm going to come over here to where it crosses. This would be the right point of intersection. Boom, boom, boom. And I want this 1.268, but I want the whole thing, so I'm going to quit out, and I'm going to store that as alpha B, 1.268. Excellent. Now they're completely in there, and now it wants me to find A plus B, so I can do alpha A plus alpha B. Now this adding them is really weird, but we actually will use this for integrals later on, so it's actually, we will use this, but that is the correct answer right there. So you actually have to graph it, find it, store it, find it, store it again, then you can do whatever. So pretty cool trick there. So I guess the recall button I should put there. If you ever just want to see what's in there, you can hit second store as recall. I can recall and see what is in. I mean, it pulls up if you want to see it, what's in there. So there's a recall button. That's anticlimactic. Bummer. All right, let's wrap it up where I think is the hardest part. Don't freak out. Just don't freak out on this. We're going to practice this. A lot of this won't even make sense. I just want to get you in the mindset. So I'm not going to kill you on this or anything. It's just to get you in the mindset. A lot of times on free responses, they like to give you weird functions. For example, methane in the cave is produced at this rate, blah, blah, blah. So the rate over time is this craziness. Okay, so I don't even know what that graph looks like. I don't know much about methane in caves, but here's the liter per hours at time t hours. It tells me the initial amount of typo, let's put an M in there, not ethane, methane in the cave is time 0. At time 0 is 20 liters. At t equals 8 hours, pump begins to remove the methane, blah, 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 blah. So that's a lot of stuff we're going to deal with, and it's going to take us all year really to get in there. But I just want to be able to see this thing, okay? So I just want to see a picture of that. So let's type this in. So part of it is just typing in this craziness. We want to type in E. Where is E? Here he is above the natural log. So I'm going to hit second E to the X. And in there, I'm going to put the sine of what? pi over 4t. Now, in this case, you're okay with just typing in pi divided by 4 because it can go pi divided by 4, and then it's going to times it by t. So you can put your x out there. So you're actually okay. If you want to use more parentheses, you can, but it can get a little weird with that. So that's the function. If you zoom standard, you can actually kind of see part of it. Like, yeah, that's okay, but it's a lot of stuff we don't need. So, and in fact, really, what should have I done? You may want to zoom trig even in this case because it's got a trig function in it. So maybe that was even better window. So that's pretty good. So it gets us going in that direction, but really we have to tweak the window, and I feel bad. This one's too easy to start with. What I'm really interested in, what makes sense. If you tell me this window right here, I'm not going to give you points. Yeah, you can see it, but it doesn't make sense for the problem. It has to make sense for this problem. So what's the key? Well, you're looking at what? You want to know 8 hours. So I need something, I'm comparing from time 0 to time 8, and then at 8 I'm beginning to remove the methane. So you need to at least, and almost all these word problems are going to start at some kind of 0, usually times 0, and maybe I want to see 12 hours. So that I need to know that you know that that is hours. So I'm showing 0 to 12 hours because at the 8th hour he's pumping it out. What do you want to count by? Probably count by hours. Do we need negative methane gas? No, you can't have negative. You can't owe somebody methane gas. So it's 0, and it looked like 4 was pretty good. That's the part I was bummed out about. A lot of times these are going to be really weird numbers, either big or small, but 4 seemed perfect. So it looked something like this. Okay, so once we have this, this is pretty reasonable right here. If you want to count this as your window, look at that. That is nice right there. Woo-hoo-hoo. I fit right on top of there. I like that. This would be a pretty good viewing window right here. Again, I don't know if it mentions this RES is the resolution. We don't ever mess with that. We always leave that bad boy at 1, and we match that right up there. Then I'm going to ask you a question. Again, we're not trying to kill, we're trying to get you in the mindset. In fact, this one is even defined interval. So for this, I'm going to only look at from 0 to 8. So when they give me that, I'm like, that's awesome. I'm looking at the first 8 hours. Boom. So I'm going to look at the first 8 hours. So again, what's going on here? Well, we're looking at the amount of methane being produced in liters per hour. So I'm in hours on. Let's just bring it so I can label some stuff. I should label some stuff. It's hard to sometimes think about what's going on here. So this is time, and it's measured in hours. And this is what? This is the rate. So this is weird to think about your y-axis as a rate, and it's your liters per hour. So it's your liters per hour. It's how fast I'm making it. So what is going on? So in the beginning, the cave is producing, it's increasing how much methane it's making per hour, maxes out, and then it's going a little bit slower in how fast it produces it. This is the lowest it ever produces, and it starts to increase more. I have no idea why caves do that. It's kind of like Mr. Bean after he had some Mexican food. What? All right, so if we're going to do this right here, let's say at what time t during the time interval 0 hours is the amount of methane increasing most rapidly? So where is he making the most amount of methane? So where is it increasing the most rapidly? Well, it's got to be right here. All right, so right here is the highest rate of change possible. So what are we going to do? We're going to come into our graph, and we're going to use one of those fancy skills we got to find the maximum. So we're going to find the maximum rate of change. So again, the y is not like the methane in liters, it is the liters per hour. It's how quickly it's releasing it. So when I find this answer, I'm finding the maximum, which is that skill we have. We've got this 2.468. So again, it's going to be very important here, 2.468. Now what is this? All right, so what does this mean? This means at 2.468 hours, that's the time. So at this time, what is going on? You are producing 2.54, let's go ahead and truncate 5 liters per hour. So that is the rate of change at this time. So luckily it said at what time t. So really this is the answer, at what time t. But I want to make sure that we're good with labeling, because sometimes it's going to ask you, well, what is that rate of change? The rate of change is 2.54 liters per hour. Make sure you label everything. If it's not labeled, it is not correct. So sometimes you have to change the y value as well. I'm going to give you a lot of practice at that on the handouts. I hope that goes well for you. That is it. That is the whole calculator skills. If you can do all that, you will be in good shape. Good luck on, there will be a little super mastery check on this that you have to pass. So good luck on that. Peace.